Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 231. Please turn to it. Page number 231, and today is our lesson number 325. This problem that you see there on page number 231 is the exact same problem that appeared in the first edition of the revised GRE. We have already done every single problem from this book in the first edition. If you're interested in watching the original solution to this problem, you will find the original solution on day number 111. So here's how it goes. We are told that we are buying apples and bananas. They say apples and pears, but apples and bananas I like better because then we can deal with A and B. Do you understand? So we are told that we are buying apples and bananas. Apples, we are told, cost 15 cents each. Bananas, we are told, cost 20 cents each. We are also told that we're going to spend a total of $3.80. And we are told that we're going to buy 21 pieces of fruit. And the question is very simple, very straightforward. The question simply is, how many bananas were bought? That's all. So let's see what we can do here. So, here's our solution. We're going to use letter A. Let A represent the number of apples we buy. Similarly, let B represent the number of bananas we buy. So the money that we're going to spend on apple, money spent on apples plus money spent on bananas has to equal to the total amount. Or not $380, but 380 cents. It's important, obviously. So the question is, how do we represent the money that we're going to spend on apples? Well, apples cost 15 cents. So if we buy one apple, we're going to spend 1 times 15 cents. If we buy 2 apples, we're going to have to pay 2 times 15 cents. If we buy 5 apples, we're going to have to pay 5 times 15 cents. We are buying A apples. Let A represents the number of apples that we're going to purchase. If you're going to buy A apples, then the total money that we'll have to pay for A apples, A number of apples, is going to be 15 times A. Voila! Money spent on apples is 15 times A. Similarly, the money that we're going to spend on bananas is going to be the price of one banana, which is 20 cents, times the number of bananas we're going to buy. We're going to buy B bananas. So it's 20 times B equals 380. This is our first equation. We're going to continue our story from this equation up here. We need the room. So we have 15A plus 20B equals 380. Now, we could actually leave everything the way it is. But it is always a good idea to simplify the equation, any given equation, if you can, before you start solving for variables that you have to solve for. Here we have to solve for variable B because they are asking us how many bananas we buy. Before we start the solution, before we start looking for the value of B, it is always a good idea to simplify the equation as much as we can. The more simplified the equation is, the less work we will have to do. That's all. So can we simplify this equation? Do you find any common factor between in these three terms, 15A, 20B, 380, any common factor? Well, they are all multiples of 5. We cannot divide 15 by 10, So we cannot divide the equation by 10, because if we did that we'll end up with 1.5, but we can most certainly divide the entire equation by 5. That's what we're going to do. Let's divide the whole equation by 5. So 15 divided by 5 is going to give us 3 apples. 20 divided by 5 is going to give us 4 bananas. And how much is 380 divided by 5? 380 divided by 5. How many 5s in 38? How many 5s in 38? Let's do it a little bit lower so we can do it here. 380 divided by 5. How many 5s in a 3? 3 has no 5s. That 3 goes and joins the 8. It becomes 38. How many 5s in 38? Well, 7 5s I know are 35s. So 7 5s are 35. The remaining 3 is going to go and join this 0, and it's going to become 30. 30 divided by 5 is 6. So it is 76. 380 divided by 5 is 76. 380 divided by 5, it turns out, is 76. That is our equation 1. Where is the second equation going to come from? We have to have two equations because we have two unknowns. We have A and B. We have two unknowns. We need two independent equations. Well, the second equation is very straightforward. We are told that we are going to buy 21 pieces of fruit. So there is the second equation. Second equation is, where is the second equation? Equation 2 is A plus B has to equal 21. A plus B has to equal 21 because we are buying 21 pieces of fruit. A represents the number of apples we are buying, B represents the number of bananas we are buying. Therefore, the total number of apples that we buy and total number of bananas that we buy, they have to add up to 21 because we are told we are buying 21 pieces of fruit. Let's multiply the second equation by 3. As long as we can make the coefficient the same, either we can make the coefficient of B the same in both equations by multiplying the second equation by 4. And if we do that, we'll end up getting rid of B, but we don't want to get rid of B because B is what we are interested in. We want to find out how many bananas we bought. We want to eliminate A. We can eliminate A if we can somehow make the coefficient of this A the same as that one. So let's multiply. Let's take our second equation, equation number 2, and multiply it by 3. This is our equation number 2, multiplied by 3, and if we do that, we'll end up with, if we multiply this equation, equation number 2 by 3, we'll end up with 3 times A plus 3 times B plus 3 times 21. 3 times 21. Here's our second equation. We multiply this equation by 3, and that's what we're writing here. So 21 times 3, 20 times 3 is 60, so 63. That's it, we're done. Now we're going to subtract the second equation from the first equation. Now as soon as we said that we're going to subtract one equation from the other, it's always a good idea to make sure that the equation that you're subtracting, not the equation you're subtracting from, but the equation that is being subtracted, you go to that equation and you change the sign of every single coefficient. So positive 3a is going to become negative 3a because we're subtracting it. Positive 3 is going to become negative 3 again here, and positive 63 is going to become negative 63. That's what it means to subtract. This positive 63 is going to become negative 63. So this positive 3a and this negative 3a is going to cancel out. 4a minus 3b is going to give b, and here 76 minus 63 is going to give us 13. There you go. We bought 13 bananas. That's our answer. 13 bananas were bought. Let's do one more, shall we? Let's do the next question on the following page. The one about the radios. Just give me 1 second here. On page number 232, problem number 6. On page number 232, problem number 6, something that we solved on day number 112. That problem has to do with inequality. Turn the page. As I said, the problem about the radio. We are told that we are producing radios. And we are told that the cost of each radio, okay, we need the room obviously, I need to raise it. Let's put it here. Cost per radio, we are told is $30. We are told that the number of radios sold, we are told is 500. We're going to sell 500 radios. The required profit has to be more than $8,200. We want to make a profit of more than $8,200, we are told. The question simply is, what should be the selling price? We are buying it for $30. Okay, you're running a shop where you sell radios. So you buy the radios from the manufacturers for $30 each. The question is, what should I sell these radios for to make sure that I make a minimum of, not minimum of 8,200 rather, but I make a profit of more than 8,200, maybe 8,201 penny, because it's greater than, not greater than or equal to. But how are we going to express the profit that we're going to make per radio? That's the first question. So here's our solution. We're going to represent let the selling price be $P. P for price. Selling price is what we are interested in. We're going to represent that with letter P, $P. For example, if we sell it for $70 and the cost is $30, we are told. The cost we are told is $30. If we sell the radio for $70, something that costs us $30 to buy, the difference between the selling price and what we paid for it, that represents our profit. Profit per radio. In this case, it will be $40. On the other hand, if we sell it for $35, the amount that we paid stays the same. It's $30 per radio is what we have to pay for. If we sell it for $35, our profit per radio is going to be $5, and so on and so forth. Here, we are selling it for $P. So our profit per radio is just this amount, P minus 30. P minus 30. That's our profit per radio. So let's continue then. So P minus 30 represents the profit per radio. And how many radios are we selling? We are selling 500 of them. Therefore, our total profit of this is the profit we're making per radio. P minus 30 is the profit that we're making per radio. We're going to sell 500 of them. So 500 times the profit per radio must represent the total profit. That's it, we are done. And we are told that this amount has to be more than 8,200. That's it. We wanted our inequality. We got it. So the inequality that we're going to solve for is 500 times P minus 30 has to be greater than 8,200. If you divide both sides by 100, we're going to knock out two zeros here. This is what I'm talking about. If you feel that you need a little bit more help, you need to show, if you feel that you need to be shown every single step, you're more than welcome to watch the original solution on day number 112. Here I'm just going to do it a little bit faster. Not too much, but just a little bit. So that's it. We divide both sides by 100. We knock out two zeros from here and two zeros from there. Now we multiply it. P times 5, or rather 5 times P is going to be 5P, and 5 times 30 is going to be 150. It has to be greater than 82. We need to get rid of this 150 from this side. So let's add 150 to both sides. And this 150 knocks out, and we end up with 5P is greater than, this is 2, 8, 5 plus 5 is 13, and it's going to be 232. 5P has to be more than 232. Let's do it on the top here. We are almost done. So 5P has to be more than 232. Divide both sides by 5 and we are done. Divide both sides by 5 and that's your P. We're trying to figure out what the price has to be. The price has to be something more than this amount in order for us to make sure that we get a total profit of more than $8,200. Let's find out what that amount is, shall we? We're going to divide 232 by 5. How many 5s in a 2? 2 has no 5s. That 2 goes and joins the 3, becomes 23. How many 5s in a 23? The 23 has 4 5s. 23 goes out, it becomes 4 5. The remaining 3 goes and joins this guy, becomes 32. How many 5s in a 32? 32 has 6 5s. 6 5s are 30. But of course it is 32, it's not 30, so we have 2 remainder. So the answer is 46 and 2/5. The price has to be more than 46 and 2/5 dollars. 46 and 2/5 dollars. Now if you don't like that, if you don't like this mumbo jumbo that I just did here, another way we could have done is this. We know that P has to be more than 232 divided by 5. 232 divided by 5. Another way we could have tackled the whole thing is multiply top and bottom by 2. When we multiply top and bottom by 2, what we end up here is 464 divided by 10. 464 divided by 10. When you divide it by 10, you just have to move the decimal place. And as soon as we move the decimal place, we find out that P has to be more than $46.40. P has to be more than $46.40, which is exactly what that is. This is same as 46 and 2/5 dollars, because a fifth of a dollar is 20 cents and 2/5 is going to be 40 cents. That's all. I will see you tomorrow. And tomorrow we're going to start a new topic, a topic dealing with the concept of interest, the simple interest and compound interest. Simple interest is so called because it's simple. It is the compound interest that we have to worry about. We're going to do a couple of problems on the concept of compound interest because they do appear in the exam, obviously, which is why they're in the book, obviously. We're going to work on those tomorrow. Okay? Bye now.